China has launched an unprecedented mission to retrieve samples from the far side of the moon.
Over the years, the moon has captivated humanity, fueling myths, igniting ambitions, and shaping history. The space race of the 20th century was a battle of superpowers, an intense geo-political rivalry between the United States and the Soviet Union. But now, a new challenger has emerged. China's latest lunar mission has uncovered something so shocking, so history-altering, that it's sending shockwaves across the world, especially in the United States. What did they find? And why is it shaking the foundations of what we thought we knew? Stay tuned to uncover the truth. China's Chang'e missions. The Chinese Lunar Exploration Program, also called CLEP, is a set of robotic missions to the moon, led by China's National Space Administration, or the CNSA. It's named after Chang'e, the Chinese moon goddess. This program includes sending orbiters, landers, rovers, and even spacecraft to return samples.
China has released the latest scientific research of its lunar exploration mission,
all launched with Long March rockets. There are also plans to send humans to the moon, with a goal to land astronauts there by the year 2030. This was announced publicly during a conference in July 2023.
China is shooting for the moon. The country plans to put its own astronauts on the moon by 2030.
The missions are tracked and controlled using a system that includes large radio antennas in Beijing, Kunming, Shanghai, and Urumqi, which form a powerful network for communication and monitoring. In 2019, Zhang Kejian, the head of the CNSA, said that China plans to build a research station at the moon's south pole within the next 10 years. The program is split into 4 key phases, with each mission helping to develop new technology for future missions. Let's take a look at each one. The first phase involved launching 2 lunar orbiters, and it's pretty much done now. The first mission, Chang'e-Y, was launched on October 24, 2007, aboard a Long March 3A rocket from the Xichang Satellite Launch Center. The launch was delayed from the original dates of April 17th to 19th, 2007. Chang'e-Y made a detailed scan of the entire moon and created a 3D map to help guide future landing missions. It also mapped the chemical elements on the moon's surface to identify possible resources. Then came Chang'e-2, launched on October 1st, 2010, aboard a Long March 3C rocket. Chang'e-2 reached the moon in under 5 days, much faster than Chang'e-1, which took 12 days. Chang'e-2 mapped the moon even more thoroughly. After that, it left lunar orbit and traveled to the Earth-Sun L2 Lagrangian point to test the tracking and communication system. Later, it flew by asteroid 4179 Tutades on December 13, 2012, before venturing further into space to continue testing the system. After the first phase, the second phase began and is still happening. This phase involves spacecraft that can land softly on the moon and send out lunar rovers.
It's the very first time China has attempted a soft landing on any extraterrestrial surface.
Chang'e-3, which was launched on December 2, 2013, aboard a Long March 3B rocket, successfully landed on the moon on December 14, 2013.
Well, China's lunar probe Chang'e-3 has moved a step closer to the moon.
It carried a lunar rover named Yutu, which weighed around 308 pounds. Yutu's mission was to explore a region of the moon covering about 1.2 square miles over a 3-month period.
Chang'e-3 lunar mission. The rover and lander have taken photos of each other for the 5th and final time.
It was also supposed to study things like galaxies, stars, and other distant space objects, as well as looking into the Earth's plasmasphere. Then, Chang'e-4 was launched on December 7, 2018.
The 4th lunar mission began as a backup for Chang'e-3. With Chang'e-3's successful moon landing in 2013,
it was originally planned for 2015, but was delayed. This mission ended up being a backup for Chang'e-3. After Chang'e-3 succeeded, the design of Chang'e-4 was modified for the next mission. Chang'e-4 landed on January 3, 2019, at the South Pole Aitken Basin, on the moon's far side, and sent out the Yutu-2 rover. The third phase involved a mission to bring back samples from the moon. For this, Chang'e 5T1 was launched on October 23, 2014, to test the spacecraft that would return lunar samples. Later, in another mission, Chang'e 5 was launched on November 23, 2020. It landed on the moon near Mons Rumker on December 1, 2020, and brought back to Earth about 1,731 grams of lunar material.
China's Chang'e mission has returned to Earth with the first fresh samples of rock and debris from the moon in more than 40 years.
Phase 4 focuses on building an autonomous research station on the moon near its south pole. The development for this phase began in the year 2023 and is part of the plan after the previous 3 phases were completed. Chang'e 6, which launched on May 3, 2024, studied the topography, composition, and structure beneath the surface of the South Pole Aitken Basin, located on the far side of the moon. It also brought back samples from the Apollo Basin, which is also on the moon's far side.
China's Chang'e 6 lunar probe's on its way back to Earth after collecting rock and soil samples from the far side of the moon.
The mission carried a Chinese rover named Jinchan, which was used to conduct infrared scans of the moon's surface and capture images of the Chang'e 6 lander. Next, Chang'e 7, which is planned to launch in the year 2026, will explore the moon's south pole for resources. This mission will include an orbiter, a lander, and a mini flying probe, but the work doesn't stop there. There will also be Chang'e 8, which is expected to launch in the year 2028. This mission will test technology that can develop and use resources found on the moon. It might include a lander, a rover, and a flying detector, along with a 3D printing experiment that uses local resources to build a structure. Chang'e 8 will also carry a small sealed ecosystem experiment and test technology for building a lunar science base. Discovery of Changesite-Y. During one of the Chang'e 5 missions, scientists in China made an incredible discovery. They found a new mineral on the moon called Changesite-Y.
Chinese scientists have for the very first time discovered a new lunar mineral, and they've named it Changesite-Y.
This mineral, which is a type of phosphate, was found in lunar basalt particles and contains helium-3, a substance that could potentially be used as fuel for future fusion energy. This discovery was shared by the China National Space Administration and the China Atomic Energy Authority in the year 2022.
Chinese researchers released new findings on the lunar samples from 2020 Chang'e 5 mission.
With this find, China became the third country, after the United States and the Soviet Union, to identify a new mineral on the moon. The name Changesite comes from the Chinese moon goddess Chang'e, which ties back to China's lunar exploration program. The discovery of Changesite-Y isn't just about finding a new mineral. It has deeper scientific importance. The mineral helps scientists learn more about the moon's geological history and how lunar basalt formed.
One of its main functions is to store the lunar samples brought back by Chang'e 5 lunar probe.
The fact that Changesite-Y contains this mineral suggests that volcanic activity on the moon may have lasted longer than scientists had originally thought, which could be helpful for identifying resources for future moon missions.
China making a land grab on the moon. That is the question, as China is bringing back samples from the far side of the moon for the very first time.
One of the most exciting things about Changesite-Y is its connection to helium-3, an isotope that could have major uses in nuclear fusion. While helium-3 is rare on Earth, it's much more common on the moon. Its presence in this mineral strengthens the idea that the moon might have resources that could be used for energy production. If fusion technology advances, helium-3 from lunar minerals like Changesite-Y could one day become an important energy source for people on Earth.
The form of the crystal, like the crystal form of this lunar sample.
To figure out what Changesite-Y was, Chinese scientists had to use some really advanced tools and techniques. They looked at the lunar samples using methods like X-ray diffraction, electron microscopy, and spectroscopic analysis. These helped them figure out the mineral's crystal structure and chemical makeup. The results showed that Changesite-Y was completely different from any other minerals found on the moon or on Earth. The analysis also revealed how it likely formed, which probably happened through high-temperature crystallization during the moon's volcanic history. In addition to Changesite-Y, the Chang'e 5 mission discovered other minerals on the moon. The samples they brought back included common lunar minerals like plagioclase, pyroxene, and olivine, which are silicate minerals often found in basaltic rocks, both on the moon and on Earth. Finding these minerals helps scientists learn more about the moon's volcanic past and its history of impacts. What's even more interesting is that the Chang'e 5 samples showed differences in mineral makeup compared to those brought back by the Apollo and Luna missions.
Big box, and literally translation is as a lunar sample transferring box.
This suggests that the moon's geological activity was not the same in all areas or at all times, but the discoveries didn't stop there. Water found on the moon. When China's Chang'e 5 mission brought back lunar samples, they made a huge discovery that could change how we think about the moon. The samples, which were taken from the Oceanus Procellarum region on the moon, showed signs of hydroxyl, a molecule closely linked to water. Scientists confirmed this by using infrared spectroscopy and other advanced methods to look at the chemical makeup of the lunar minerals. They found the hydroxyl mainly in a phosphate mineral called apatite, which had trapped the molecules inside its crystal structure. This finding adds to the idea that the moon might have its own water, instead of just water brought there by comets or solar wind. The fact that water was found in the Chang'e 5 samples is a big deal for the future of lunar exploration.
Now, the Chang'e 5 rover completed its mission in 2020, returning to Earth with rock and soil samples from the moon.
Water is a vital resource for humans, and if there's water on the moon, it could cut down on how much we need to send from Earth. If we can figure out how to extract and use this lunar water, it could be used for drinking, making rocket fuel by splitting it into hydrogen and oxygen, and even help with building long-term bases. This discovery makes the idea of humans living on the moon, especially near the South Pole, where there might be even more water ice in permanently shadowed craters, much more possible. This discovery challenges what scientists used to believe about the moon being completely dry. Before these recent findings, most scientists thought the moon had no real water because it doesn't have an atmosphere and gets hit with harsh solar radiation. Past lunar missions, like Apollo, returned samples that showed almost no signs of water. But with modern tools, scientists have found small amounts of hydroxyl and water ice in different places on the moon. The samples from Chang'e 5 provide clear proof that water exists even in the moon's sunlit areas, suggesting that water might be more common on the moon than we thought. This discovery is making scientists rethink the moon's geological history and how water plays a role in the formation of planets. However, China wasn't the first to find water on the moon. The idea of water on the moon was supported by other missions, like NASA's SOFIA telescope, which spotted water molecules on the moon's sunlit surface, and India's Chandrayaan-1, which first noticed hydroxyl signatures back in 2009. The Chang'e 5 mission's discoveries add to this growing collection of evidence, especially since they brought back actual samples for lab testing.
Chang'e-Wu, or Long March 5, is on a historic mission to bring back rock and soil samples from the moon.
This helps scientists understand more about how water forms, is stored, and maybe even gets refilled on the moon. There are a lot of ideas about how water got to the moon, and while no one theory is fully proven, the evidence points to a mix of sources. One popular idea is that hydrogen from the solar wind reacts with oxygen in lunar minerals to form hydroxyl and, in some cases, water. The sun constantly sends out high-energy hydrogen ions that hit the moon's surface and react with the oxygen in the moon's rocks. Over time, this process could create small amounts of water, especially in places where there are lots of oxygen-rich minerals like silicates. Some scientists think that water might have come to the moon from comets and asteroids that hit it over billions of years. Comets are mostly made of water ice, and some asteroids have minerals that contain water. When these space objects collided with the moon, they could have left behind water in the form of ice or hydrated minerals. Some of that water might have stayed stuck in permanently shadowed craters, especially at the moon's poles, where the cold temperatures are just right to keep ice around for billions of years. There's also the possibility that some of the moon's water came from inside the moon itself. In the past, lunar volcanic activity could have released water that was trapped in the moon's magma. and that water eventually became part of the minerals on the surface. The presence of hydroxyl in minerals like apatite, found in samples from both the Chang'e-5 and Apollo missions, supports this idea. It suggests that water was already inside the moon when it first formed and was later brought to the surface by volcanic eruptions,
with hopes of learning more about the moon's origins, formation, and volcanic activity.
On top of that, micrometeorites, which are tiny space rocks that constantly hit the moon, might also play a part in creating water. When these small rocks hit the lunar surface, the impact creates intense heat that can melt or vaporize the moon's minerals. This heat could trigger chemical reactions that form hydroxyl or even water molecules. Once they're formed, these molecules might get stuck in the moon's surface dust, called regolith, or they could move to colder areas and turn into ice. Finally, some research suggests that water on the moon might not be stuck in one place. It could actually move around, depending on the temperature. For example, water molecules might be stored in the moon's surface dust, known as regolith, during the cold lunar night, and then released into the moon's very thin exosphere during the day when it gets warmer. This possible water cycle on the moon is still being studied. The United States react to China's lunar mission success. China's Chang'e missions have really pushed the limits of lunar exploration, and it's made the United States sit up and take notice. Reactions in the United States have ranged from surprise to admiration, but also a bit of strategic reevaluation. The speed at which China's lunar program has moved, especially with the Chang'e-5 and Chang'e-6 missions, to take a close look at how it affects America's space plans. The discovery of new lunar minerals and the successful collection of samples from the far side of the moon by China's Chang'e missions really caught the U.S. scientific community off guard. The Chang'e-6 mission, launched in May 2024, was a huge step forward when it brought back soil samples from the moon's far side, something that hadn't been done before. When these samples were analyzed, Chinese scientists found that they had distinct characteristics compared to those from other parts of the moon, giving scientists new clues about the moon's history. On the political and scientific fronts, the United States response has been mixed. NASA Administrator Bill Nelson recognized China's accomplishments, pointing out that China now aims to land astronauts on the moon before 2030, while the U.S. is aiming for the latter part of 2026. He also mentioned the tough nature of space exploration, especially human spaceflight, saying, "Spaceflight is hard, but human spaceflight is even harder and much more difficult than a robotic landing." China's progress in space has sparked a lot of discussion in the political world, especially about whether the United States can maintain its top spot in space exploration. The diplomat pointed out that the United States lunar program is behind schedule, while China is set to put astronauts on the moon by 2030, and the Chinese tend to stick to its timelines. This has led to calls for the U.S. to speed up its own lunar plans to avoid falling behind in the race to space. China's achievements in lunar exploration have made a big impact on the United States' plans.
To their Tiangong space station, starting a new page in their space exploration effort.
The success of the Chang'e missions not only shows how much China is advancing, but it's also pushed the United States to rethink its goals and timelines. The Guardian reported that, as China sends its Chang'e-6 mission to the far side of the moon, U.S. officials are growing concerned about how fast China is moving. In response, NASA has been pushing forward with its Artemis program, which aims to bring astronauts back to the moon. However, delays in the development of key equipment, like spacesuits and lunar landing vehicles, have created some roadblocks. The diplomat mentioned that the United States lunar program is delayed, partly because the spacesuits and lunar landing vehicles aren't ready. Even with the competition heating up, there are signs that the United States and China might collaborate. Reuters reported that NASA and Chinese officials are in talks to allow American scientists to study lunar samples that China collected during its Chang'e-5 mission in 2020 and Chang'e-6 mission in 2024. This is a shift in the U.S. strategy, as they look to avoid mistakes in space operations, even while still competing for dominance in space. NASA Administrator Bill Nelson has assured Congress that these discussions don't pose any national security risks. Can China overtake America in the lunar race? China's lunar program has reached some impressive milestones, showing its strengths in careful planning, coordinated execution, and tech innovation in ways that sometimes surpass the United States. One of the main advantages of China's approach is its government-run space program. This setup lets them plan long-term and use resources more effectively. The Wall Street Journal points out that, unlike the United States, which often works with private companies like SpaceX for space missions, China has a more centralized system that helps it keep a single vision for its projects. China's step-by-step strategy has also been a big part of its success. By building on each mission's progress, China has gradually improved its skills. The Guardian notes that China's lunar program has followed a series of well-thought-out missions, with each one setting up the next. In addition, China has been really good at sticking to its deadlines. The diplomat mentions that China is known for meeting its space exploration goals on time, unlike the frequent delays the United States faces. China's Chang'e missions have shown some impressive leaps in technology. For example, the Chang'e-5 mission brought back lunar samples.
First spacecraft designed to retrieve samples from the moon's far side.
And the following Chang'e-6 mission successfully returned soil samples from the far side of the moon, something no one had done before. These missions have given scientists fresh insights into the moon's history and have been celebrated as big wins in lunar research. What also sets China apart is its focus on working with others. Instead of going it alone, China has teamed up with other countries, sharing data from its missions and promoting a more collaborative attitude in the global space community. This is a bit different from how the United States often approaches space, with a more competitive edge. Additionally, China has strategically focused its efforts on the moon's south pole, a spot thought to hold valuable resources like water ice. This shows that China is thinking ahead, targeting specific areas that could be key for future exploration and even for using those resources, giving it an edge over broader, less targeted exploration plans. But that doesn't mean the United States hasn't also made huge strides in lunar exploration too.
Beijing is aiming for a record year of lunar exploration, but the US is growing increasingly alarmed.
In fact, there are some areas where the US has far outpaced China. For example, the United States is the only country to have sent humans to the moon. Through NASA's Apollo program, astronauts first landed on the lunar surface between 1969 and 1972. Over those missions, 12 astronauts walked on the moon, a feat no other country has matched. These missions weren't just about making history. They also gave scientists crucial data that still impacts lunar research today. Beyond sending humans to the moon, the US has also led the way in space tech and innovation. NASA's Artemis program, which plans to return humans to the moon and set up a long-term presence there, shows that the United States is committed to continuing its lunar journey. While China's government-run space program has advantages, the United States has built a stronger partnership with private companies like SpaceX and Blue Origin. These companies have been key in developing technologies that could make future lunar missions more cost-effective and efficient, like reusable rockets and lunar landers. These collaborations with private companies have helped the United States stay ahead in certain areas, something China hasn't fully embraced yet. The United States has built a strong reputation as a leader in space exploration, not only through its own missions, but by supporting the global space community.
Shows its own confidence in its growing space ambitions.
NASA's role in the International Space Station, along with its collaborations with organizations like the European Space Agency, or ESA, and the Japanese Aerospace Exploration Agency, or JAXA, has helped cement the United States' position as a major player in space. While China has made progress with its Chang'e missions, it has faced challenges in collaborating with other countries, mainly because of political factors. Another area where the United States shines is in scientific research and sharing valuable data. NASA's Lunar Reconnaissance Orbiter, or LRO, has created detailed maps of the moon's surface, which are crucial for future missions. This data is openly shared with scientists around the world, helping foster international cooperation and allowing lunar exploration to benefit from a wide range of expertise. On the other hand, China has been more protective of its data, keeping certain findings from its lunar missions private. In a nutshell, while China has made impressive progress in exploring the moon, it hasn't yet built the same level of infrastructure for sending humans there. NASA's Artemis program has big plans for the future, aiming not just to send astronauts back to the moon, but to create a lasting human presence. Part of this plan includes building the Lunar Gateway, a space station that will orbit the moon and serve as a key launch point for future missions to Mars and beyond. As far as lunar missions go, the United States still leads in areas like human spaceflight, tech innovation, international partnerships, and long-term goals for sustainable lunar missions. What's interesting is that the gap between the two countries in this lunar race keeps shrinking, which makes you wonder if one day the United States and China could set aside their differences and join forces. Will the United States and China collaborate on a lunar mission? A partnership between the United States and China in space exploration is a complicated idea, shaped by political, technological, and economic factors. Even though both countries have achieved a lot in space, their long history of tensions and global politics has made it difficult for them to work together fully. Still, there are more and more people arguing that such a partnership could be possible in the future, especially when it comes to big projects like an international space station or missions to the moon and Mars. Right now, the United States and China don't work closely together in space exploration. The main reason for this is a policy from the United States government that prevents NASA from working directly with China. This policy is based on national security concerns, like the fear of intellectual property being stolen, technology being misused, or military risks tied to sharing sensitive space technology. Because of this, even though both countries have top-tier space programs, they haven't had much chance to team up on space missions. There's an interesting possibility that the United States and China could work together in space in the future, especially when it comes to big projects like an international space station or other shared space goals. Both countries understand how important it is to have humans living and working in space, and the chance for collaboration could grow as global politics change. The idea of having a network of space stations like the ISS is something that space agencies worldwide have talked about. While the ISS is a joint effort between NASA, Russia, Japan, ESA, and Canada, China has built its own space station called Tiangong, which it finished in 2022. Tiangong's success shows just how much China has advanced in space exploration. However, because of the U.S. ban on NASA working with China, the U.S. hasn't been part of China's space station projects.
Tianwen-1, which translates to Questions to Heaven, hopes to find some answers on Mars.
Still, as space missions get more complex and need more global teamwork, the chance of a United States and China collaboration seems more possible. The ISS has already shown that countries with very different political systems can work together in space. Even though the United States and Russia don't always see eye to eye, they continue to cooperate on the ISS, focusing on science and exploration. This example could inspire the United States and China to eventually collaborate too, but it would take some changes in the political atmosphere. In fact, lately, there have been more signs that the United States and China might be open to working together in space, even if it's not through direct partnerships. NASA has shown interest in sharing information with China about missions to the Moon and Mars, and both countries have looked into joining international space events and projects. The future of China's space exploration. China's progress in lunar exploration has really strengthened its place in the global space scene, showing its dedication to advancing space technology and research. These achievements not only highlight China's growing tech skills, but also show how serious it is about tapping into the moon's resources and potential. President Xi Jinping has emphasized how important space exploration is for China, saying, "There is no end for space exploration." This quote reflects China's ongoing push to move forward with its space program and explore what the moon has to offer. Looking ahead, China has set some big goals for future lunar missions. Another Chang'e mission, which is set to launch in May of 2024, plans to bring back samples from the moon's South Pole Aitken Basin, an area that scientists are really interested in. Plus, China has plans to build a lunar base near the moon's south pole by the year 2035, with an even larger version expected to be finished by 2050. China's ambitions don't stop at the moon. They've also set their sights on Mars and other planets. In 2021, the Tianwen-1 mission made history by landing a rover on Mars, marking China's first mission beyond Earth's orbit. Looking ahead, China plans to send humans to Mars by the year 2033, with additional missions lined up for the years 2035, 2037, 2041, and beyond. These missions will focus on setting up a permanent base on Mars and studying its resources.
This is one of 100 launches they're planning this year as they try to rival the United States.
China is also stepping up its efforts in astronomy. They've put money into building high-tech telescopes to boost their space exploration projects. The Shanghai Astronomical Observatory recently announced the launch of 2 new radio telescopes, each with 80 feet wide antennas, located on Chang'e Mountain and in Changesite, Tibet. These telescopes are meant to help with China's lunar missions and advance radio astronomy research. China's past successes in lunar exploration and their future plans show just how committed they are to expanding their space exploration efforts. With their smart investments and bold goals, China is working to increase its role in space, adding valuable insights to our understanding of the Moon, Mars, and the wider universe. Thanks for watching. See you in our next video.